it's all about. I'll have you in the limits yet, but we know how to teach you them. It's alright, 'cause we got all you need to learn them. Limits can be such a pain. Throw every last bit away. Let's all go to calc today. Check your growth rates, check them in your textbook. They're in order of increasing value. Lots of radicals and polynomials. Exponentials next. Now for discontinuity. You know that there are two types. A whole makes it removable. Non-removable, the curve when there's a jump there. Don't forget this too fast. Limits can be such a pain. Throw every last bit away. Let's all go to calc today. What if the limit does not exist? How will you know if it is? If it approaches two different numbers from both sides, it won't exist. If it oscillates between two values as x approaches c, increases or decreases out of bounds, obviously the limit does not exist. It will. Let's go to calc. Can be such a pain. Throw every last bit away. Let's all go to calc today. Everybody loves calculus. I love calculus. Today, let's go to calc. Today. Today. Yeah. Okay. Can you laugh at
Find the limit.
The limit is -1.
I'm sorry, that is incorrect. Will, do you know?
Limits. That was the week that Bobby got his haircut. Okay, focus, Will. What was on the board behind Bobby's head? If the limit never approaches anything, the limit does not exist. The limit does not exist!
That is correct!
Yes!
Note that if both sides of the graph are approaching the same spot, the limit would be infinity, such as in this case. In the case of a horizontal asymptote of 0, as x is approaching infinity, the limit would be 0.
A limit exists as long as the limit as x approaches c from the left equals the limit as x approaches c from the right. In this case, the limit is 2 because as x approaches 3 from the left, y approaches 2. And as x approaches 3 from the right, y also approaches 2.
Oh, okay.
If the y value is only approached from one direction, the limit is considered a one-sided limit.
I get it. The y value for -3 is undefined in this equation. However, the y values from both sides are approaching the same number, so the limit as x approaches -3 is...
-6! To solve the limit algebraically, you're going to plug in 0 to this equation. But then you'll get 0 over 0, so you have to simplify it by pulling out an x from the numerator, and the x's will cancel out. Then you plug in 0 again, and then you'll get the limit. Awesome!
Okay, so there are 3 continuity conditions. The first is that f of c must exist. The second is that the limit as x approaches c of f of x has to exist also. And the third is that they have to be equal to each other.